I've been seeing a lot of questions online about the future of Sharkbyte. There's a lot of curiosity and excitement about it, which is cool to see and it's fun to be a part of that, but I've also seen a lot of skepticism around the system and where it's going. Some of you are wondering when we'll start to see more hardware coming out, maybe more VTX options or premium goggles or just bind and fly drones with Sharkbyte built in. I think some of you might also be worried about whether Sharkbyte is an open system that'll encompass products from a bunch of manufacturers, or if it's just Fat Shark's version of DJI, a proprietary system that only they control and contribute to. I've had these same questions myself, and I decided to do some investigation and figure out what's going on with Sharkbyte and what the future potential is for innovation, and whether we might see it spread to more products from more companies in the future. In this video, I'm going to tell you what I learned. First, I need to give you a little bit of background on the history of Sharkbyte and how it was developed. Let's start with this. Fat Shark didn't make Sharkbyte. That might surprise you because all of the packaging says Fat Shark, it's displayed on their website, and we know the system is Sharkbyte. But it turns out there's a lot more going on behind the scenes. Sharkbyte is actually a technology called HDZero, and it was developed by a semiconductor company named Divimath. They've been working on the system for years now, and they've developed a series of application-specific integrated circuits, or ASICs, for transmitting and receiving digital video at a very low latency. These are the semiconductor chips that power the VTX and receiver modules for Sharkbyte, and if you've looked closely at one of the VTXs, you might have even noticed the Divimath name on those chips. There's a lot to that HDZero technology. Now, obviously there are other digital video transmission systems like DJI and many others, but Divimath is focused on low and predictable latency with their system, and they've developed some cool techniques to make that work. I'm not going to get too much more into that in this video, but you need to know the brand name HDZero and understand that it's a Divimath product that Sharkbyte uses under the hood. And as a quick side note, if you do want to know more about how HDZero works on a technical level, I think Chris Rosser is making a video on that, or it may already be out, and he definitely knows what he's talking about, and he has a great accent, so I'd point you to that. I'll link it in the description of this video once it's available. So as it turns out, Divimath is the company that designed all of the current Sharkbyte transmitters and the receiver module that we're using. This includes both the hardware and software components of the system. I don't think they directly manufactured the cameras, but they work closely with Foxeer and RunCam to make their cameras work in the system. And as far as I know, Fat Shark's part in designing the current hardware has been limited to the Scout HD goggles and the casing for the existing receiver module. They're also obviously handling the distribution and frontline support of all the products. So if Divimath made all of it, why do we know it as Fat Shark Sharkbyte? Well, Divimath made some type of licensing deal with Fat Shark to allow them to brand the equipment as Sharkbyte and sell it under their own name. I don't know all the specifics of that deal, but I do know the most important part, which is that it's not an exclusive agreement. Fat Shark is able to sell the Sharkbyte gear and create products that use the technology, but they don't have the sole claim to it, and they can't stop anyone else from making products that are also compatible with HDZero and therefore Sharkbyte. I think that's something that a lot of us might find surprising, and that's one fact that has a lot of impact on what could happen in the future. So when we think about the future of Sharkbyte and what the possibilities are, we really want to look more closely at Divimath and what their approach is with HDZero. To try to get to the bottom of this and get some real insight into what's going on, I spoke with Carl Zhao at Divimath. Carl created most, if not all, of the technology, and he's definitely the best source we could possibly hope to get about what Divimath is doing and how they're thinking about this. And I think it's pretty interesting, but it's also not that surprising or unusual. You'll see why and how their approach makes sense. Divimath is a semiconductor company, and ultimately their goal is to sell chips. I mentioned those ASICs earlier that power the HDZero technology and appear on the Sharkbyte VTXs. Those ASICs are the DM5680, 6300, and 6302, and Divimath would love nothing more than to sell a lot of those chips. So they're completely open to selling those ASICs to any company that wants to build a product using the HDZero technology. There are no limitations on what that could be. So another company could build a competitor to the Whoop VTX or the Scout HD goggles or anything they wanted. And what Carl told me is that Divimath would help them do it by providing them with information on how the circuits around these ASICs are designed, and even by giving them the source code for the software that communicates with the chips. I was able to verify some aspects of this myself. I'm going to link to Divimath's website in the description of this video, and I was able to get on their site and find a fair bit of information about how their chips are used together in a system and what the capabilities are. I wasn't able to find a full data sheet for the ASICs, but the information I did find makes it clear to me that they aren't trying to build some kind of black box proprietary system. The other thing that makes me trust what they're saying here is that they're a semiconductor company and they're doing exactly what a semiconductor company should be doing. And this type of thing happens all the time. It's the way that most electronics are developed. Let me give you some examples. First, let's take a quick look at the Raspberry Pi. Most of you have probably heard of these or seen one, but it's a little single board computer that's really popular for learning and electronics projects. The Raspberry Pi Foundation designed this board and they'll sell it to you for about 30 bucks, and it's their product with their name on it. But the processor that powers the Raspberry Pi is an ARM chip made by Broadcom. Broadcom is a different company, and they'll happily tell you how to buy an ARM chip from them and how to integrate it into your design and how to work with it, but they won't tell you exactly what's inside the chip itself. That's how their business works. Another example that hits maybe closer to home for us is analog FPV video. We'd consider analog video to be pretty open. There's a lot of companies making products that all work together to transmit and receive analog video. There's the Rapid Fire, SkyZone Steady View, TBS Unify, all-in-one flight controllers, and just tons of products from different manufacturers that all work on this same standard. And it turns out that there's one company supplying the chips that power almost every product in this space. It's a company called Richwave, and they make the RTC 6705 and 6715 ASICs for transmitting and receiving analog video. I looked at the flight controller for my Mobilite 7, and sure enough, there's an RTC 6705 right there on the board. Richwave's business is selling these and other ASICs, and you can actually buy them online if you want to. I was able to find a datasheet on their website that described how to send commands to the chips, and any manufacturer can buy these and make whatever product they want to with them. They might start to sound a little familiar. So you can probably see that Divimath's approach is pretty similar to these examples. They aren't open sourcing the inner workings of their ASICs because that's their intellectual property and they spend a lot of time and money creating it. It's their product. But on the other hand, their business is selling these chips, and the best way for them to do that is to help other manufacturers integrate those chips into compelling products that will sell in the FPV market. And of course they aren't placing restrictions on what products those manufacturers can build, because that would just be limiting the potential success that they might have in selling their chips. They aren't worried about other companies competing with the existing VTXs or receiver because they ultimately created those products to drive interest in HDZero and prove to consumers and manufacturers that it's a technology they should want to get on board with. That's why it's so important to know that Fat Shark didn't develop the Sharkbyte products and doesn't have an exclusive claim to the technology. You can imagine that Fat Shark might be unwilling to offer their technology to other companies because that could easily end up with those companies making products that compete with their own. But on the other hand, Divimath is clearly incentivized to spread this technology out and get as many companies using it as possible. Okay, so I know that was a lot of background about the development history of HDZero and how Divimath and Fat Shark are related, and you're probably wondering, what does this actually mean for me as a consumer? Well, ultimately we're gonna have to wait and see, and I don't know any more than you do about any specific future products that are being developed. So I'm giving you my opinions now. But I personally think that all this should give you a really positive outlook on the future of HDZero. I was really impressed by what I heard from Divimath about their goals to make this an open system with compatible products from the different manufacturers. I think it's clear that they have a strong business incentive to do it, and we can judge by their actions that they're willing to go to great lengths to make it happen. From what I've heard, they're working very closely with the manufacturers that are making compatible products to make sure that those efforts end up being a success. The new Micro HDZero camera is an example of that. It's manufactured by Runcam, but the Divimath team's been working directly with them on the development of that camera. And if you recognize Carl's name earlier, you know that he's always on the Facebook groups and forums online directly helping people and getting feedback to make things better. There aren't that many companies in FPV doing that sort of thing. Now, I do think we have to be fair and say that these policies and intentions haven't fully been put to the test yet. We haven't seen too many HDZero compatible products from other manufacturers, and I think that some of you may not fully believe all this talk of an open system until you see that. I think that's an understandable perspective, and it's natural for us to be skeptical until we see proof. But from everything I'm seeing myself and what I'm hearing from Divimath, I think there's a lot of willingness from them to make this happen as soon as other manufacturers are ready to jump on board. I think there's a really bright future ahead here. Seeing the basis of the technology and understanding the approach Divimath is taking with it, I think it's pretty likely that we will see more products that work in the system. It's hard to imagine anything really killing analog video, but I think HDZero has a good chance of becoming a more common part of FPV. So guys, that's going to do it for this video. I know this was a little different from my normal content, and hopefully you enjoyed seeing some of the inner workings of how some of these companies in FPV interact and how their businesses work and what their goals are. I really would like to know if that's something you'd like to see more of, so if you did enjoy this, please give this video the thumbs up and consider subscribing. And if you do have any questions about this stuff, leave a comment below and I'll try to get you an answer. Thanks for watching, and I'll see you in the next one.